Okay, so let us start, guys. I hope so that I'm audible. Everything is online. Right. Okay. Welcome back to Coders Arcade, guys. This is your Ashank David, and in today's live session, this is going to be the 16th live session of DSA for placement series. And in this series, we are learning DSA. If you are new to this channel, I would request you people to please do like, share and subscribe to this stream, and also don't forget to press the bell icon so that you won't miss any future updates. Well, for those people who are new to this live session, we are actually learning DSA, and in this DSA is for placement. So if you also want to learn anything for this placement series, you can come here and you can understand all the sessions. Well, I am Ashank David and I'll be teaching you everything about data structures and algorithms, and our today's concept is going to be trees data structure. Our today's concept would be trees data structure. So let us start. I hope so that whatever we have done in the previous sessions we have done our stacks, we have done our queues, we have done a linked list we have done singly, we have done doubly, and now we are going to start with the trees concept. We have done stacks, linked list, we have done queues, linked list, and now we are going to start with our trees data structure. In between, sometimes I will be taking up some random questions that can be helpful and useful for your placements. But today we are starting with our new concept here, all new with the fresh mind here in this series, and that is going to be trees data structure. So without any further ado, let's get right into the topic. And before I start with this live stream, I would like to ask you to share this stream as much as possible, so those people who wanted to learn DSA can also learn DSA from us. Now let us start the class. So here in today's video, we are going to talk about the trees data structure. Trees data structure. Okay. So what exactly is trees? In terms of data structure, this is one of the data structures which allows us to basically keep all our data into nodes in a tree like hierarchical structure format, which allows us to do multiple different things, multiple different kinds of features we can make use of it. In this case, it is what? It is the first non-linear data structure that we are learning in this live session. It is the first non-linear data structure that we are starting on this channel in this live data structure sessions. So it is non-linear. Okay, non-linear means, unlike till now you have studied about stacks, queues, linked lists, these are all linear data structures where everything is placed into a linear format. Okay, there can be multiple uses of linear data structure and there are different uses of non-linear data structure. Now you can see that tree is going to be a hierarchical format. It will be kept into a hierarchical format, so that it will look like a tree data structure basically, where we will have levels from above to below. Okay. So all of these things will be covered. Okay. Muhammad Irfan, hello sir. Oh, message got deleted. The second message got deleted. Okay. Ask whatever you want to ask, Muhammad Irfan. I am there to clear your doubts. Welcome to our live stream. Today you have any doubts, I will be there for you for the doubt clearance. Yes, I am good. How are you? Let's continue the class. Okay, we are learning about trees data structure here, and we are going to understand about what exactly is tree, and 2-3 days we will be focusing on to trees data structure. Okay, we will go into everything about trees data structure in depth. About we will talk about DFS, BFS, traversal, nodes, branches, everything. So stay tuned for more stuff like this and you will learn a lot. Okay, so let us continue here. It is a non-linear data structure and it allows us to store the data into nodes which are connected to each other with the help of branches. It has the concepts, the data is stored in different nodes which can be divided into root, branches and leaf. This is the terms that we use in terms of trees data structure. Yes, graphs will actually come after this, Irfan. So we will do trees, then we have to do a little bit of priority queues, and then we will come to graph data structure. So yes, I will be covering that as well. Okay, so we have the root, branches and leaves. Now one thing that you might have noticed about that I am using the word here called as root. Root. Yes, actually this root data structure, this root is the same as the head in the linked list. In the linked list we were talking about head pointer, right? But in this tree data structure we have root pointer. In this case root will be exactly a node itself. There in the linked list concept, the head was just a pointer. Head was just pointing towards a particular node. That other node was storing the data. Okay, so head pointer was pointing towards the data. Head pointer was not storing the data in itself, but here the root node will be storing the data into it. How does a tree data structure looks like? Let us first create it and understand how it looks like, so that you understand in a much better way. Harshavardhan Reddy, Jala, is this live classes continues every day, sir? Yes, it continues every day. For this week I have decided the timing at 7 o'clock, but generally every evening at 6 o'clock I continue coming live for you guys to teach DSA for the placement series. Thank you, the one. I hit the bell icon. Yes, thank you so much. And stay tuned for more contents like this. Okay, coming back to our point, I was saying that how you would understand how trees are created, how does a tree data structure looks like. So generally tree data structure will look like this. I'll create a proper version of trees. So here we will create so basically this is going to be our node where I will be storing some data. Then this node will be actually connected with other nodes like this on its left and its right, like this. Okay, then these nodes, so there can be multiple nodes connected to each other. In this case there can be multiple nodes connected to one single node. In this case, okay, like this, there can be multiple nodes. Okay, more nodes connected to more and more nodes. This is how your tree data structure it looks like generally. Okay, you see that this is an hierarchical format where the data is stored into the nodes. These circles are what you call as nodes, and these lines which we are creating here, these are what? Branches. These are branches. Okay, these are branches, and the last nodes, the ending nodes, what you see here are what you call as leaf node. Leaf nodes. As I told you that we use this terminology of root, branches and leaf to tell about how does a tree looks like and how does it stores the data. So these are the terms that we use into our tree data structure. So this is how your regular tree data structure looks like, where this is your normal tree here, where in this case this is what it is, it is just a normal regular tree data structure. This is the normal regular tree data structure, where you can see that n number of nodes are connected to n number of nodes. Sir, is it possible to make a separate session for the shortest path of graphs, as you told me that you will arrange some special sessions? I have many doubts about Dijkstra's algorithm, Bellman-Ford and Prim's. Yes, I will do that. Give me some 1 or 2 days time. Yesterday I also told you that give me 1 or 2 days time. I have some college going on right now, college project going on. So till this week I am busy in one of the colleges. So till tomorrow I am in the college, but day after tomorrow and after that I will be able to help you. By this weekend I will definitely help you and do something about your topic and doubt. So Mohammed Irfan, you have to wait a little bit, just give me some time and I will be helping you out with it. I'll create a special video, I'll create a special video on explanation of Dijkstra's algorithm and coming live onto it. I will tell you, I will help you, don't worry about it, okay. I will clear it, don't worry. I have knowledge about SQL and PL. SQL is good to 10LP. It depends upon different companies, Sanjay. It depends upon different companies. It is up to the company what they want actually into the companies as their position or whatever is the available position. Let us continue into this. Okay. Let us continue into this session. Okay. So as I told you, this is your regular tree data structure. And in this case, this is how your regulatory data structure looks like. Here inside we will store some data. You see, we are storing some data. I have this 4, this 5, 6, 7, 8, maybe 9 here, 10 here, 11 here. So you see that the data is stored inside the nodes, and this is how you see a tree data structure. But the thing is that this is not actually what you learn in DSA. This is how it looks like, but this type of tree we don't learn in terms of DSA for your placements. What we actually learn is another type of tree that is very famous, and today I will be telling you about that. If we talk about the types of trees, there are different kind of trees. The most prominent two types are: number 1, a regular binary tree, which is generally asked in placements. Okay. The next one is the binary search tree. Binary search tree. In short form, we also call it as BST. This is what we call as BST in short form. Okay. Third one, there are now many types of trees. One of the famous ones are AVL tree. Then we have splay tree, SPLAY, splay tree. Then we have red and black tree. A lot of different kinds of trees are there, and the list goes on, etc, etc. Okay, a lot of different kinds of trees are there. I hope so that you got my point. Today we will be focusing on to these two for now, but as the class continues on to, we will be doing our AVL tree, splay tree and red and black tree also in this series of live sessions that I am creating right now. Okay. So when the time comes, I will be doing that, but the main point of focus for today's class is gonna be binary tree and binary search tree. We will continue here. So in this case, when we are talking about trees data structure, the major two types that is most probably and mostly asked in general, the questions are even asked from this kind of trees, and that is going to be our first one, binary tree. Okay. So what is the difference here? What is the difference between a normal tree which I have shown you before and a binary tree which I am talking about right now? So it is like this. It is just like this. A normal tree can connect n number of nodes with n number of nodes, it does not matter. As you can see here, a small structure I have created here. Okay. So, any number of nodes can connect with any number of nodes like this. Got it? But in this case, in binary tree, this is your regular normal tree data structure. But in your binary tree data structure, this is the one node. Okay, this is what? This is, let's say, a root node. The property of a binary tree says that, the rule for binary tree says that, why the name came binary? It says that max to max, a node can be connected to max 2 nodes or 1 node or 0 node. Max to max 2 node, minimum 0 node. That is the property. In this case of this normal tree, the node was getting connected with many different nodes. There were n number of nodes connected with n number of nodes in this case. So, in this case of binary tree, 2 nodes are connected max to a single node, and it depends how many nodes you want in your program, how many nodes you want in your binary tree, and depending upon that it keeps on going. Now, for example, this is a binary tree, and if I say here this node does not have any other child node, and here we have only one, but here we have 2, let us say, like this. This is a binary tree in this case. I hope so that you got my point. This is what? It is a binary tree, where you can see that every node, in this case for example, this is a root node and it has 2 children. We say 2 children, here these are the 2 children of this node in this case. So, this is children on the left hand side, this is on the left side, and this is on the right side. On the left hand side you have this one children and you have second children. Here this children has its own children. So, on the left hand side of this children, and this is the right hand side of this children. Now, this children has its own children, but it has only one child, and that is on the left hand side. So, like that. And here this guy has its own children divided more, and they have their own children. Like this, the tree is getting created. So, this is, every node will have its own left and right depending upon what exactly is happening and what do you want in the program. I hope so that this is very much clear to all of you into this. Okay. Now, as you have understood this, so rule of BST says, rule of BT, binary tree. We are not doing BST right now. We have not started with the BST. I will tell you about BST in a moment. Right now I am saying this is binary trees. In binary trees, what happens is that total number of nodes, here number of nodes max connected to a node can be 2 in this case. This is important. Number of nodes max connected to a node can be 2 here, not more than that. Minimum it can be 0 or 1 it can be. This is the major rule of binary tree. I hope so that this is very much clear to all of you. Speaking about the second type of tree that we are mainly focusing on to, that is binary search tree. Now, what is the difference between a binary tree and a binary search tree? A binary search tree is also a binary tree. Ultimately, it is a binary tree only, but we have added one word here called as search tree. Now, what is the meaning of this search tree? When we add this word here called as search tree, we are trying to say something here. In this case, the property of this binary tree is changed a little bit and a new tree is created. In this case, what happens is that a binary tree looks like this, where we will have a root node. Of course, we will have a root node, but let us say, imagine there is 100 stored here. There is 100 is stored here. Okay. Now I said that I want to insert, let us say 50. In binary search tree, what happens is the value has to be compared with the root node, and depending upon its value, we are going to put it either on the left hand side or in the right hand side. This is the rule of BST, that here let us say this is 50. Now you tell 50 is greater than 100 or lesser than 100. Of course 50 is lesser than 100. Any item which is lesser than the node here will be taken care of as a left child. So 50 will be placed right here. I hope so that this is very much clear. So 50 has to be inserted. 50 will be inserted on the left hand side of the root. Why? Because it is smaller. BST rule says that in BST rule is, the BST rule is that, binary search tree rule is that smaller nodes smaller nodes will be put onto the left hand side. Okay, will be put onto the left. Okay, it will be put onto the left hand side. Okay, but the larger nodes will be put onto the right hand side. Okay, will be put onto the right hand side. Is that clear? So let us say now I am inserting 150. Of course 150 will be compared with the root node, and when we are trying to compare it, we know that 150 is actually greater than the root value here. So this 150 will be inserted on the right hand side. So here we will insert 150 right here. I hope so that this is very much clear to all of you. Okay. Sir, I want to recommend something. Sir, can you please make a short point on the side and some key points also? I want to recommend something. Sir, can you please make a short point on the side and some key points also? Yes, I will do that. Here I am doing it. Okay. I am doing that. Well, I will be giving the link of this whole thing, like by using an array to run on board fully, then go to VS Code, like by using array dry, run on board fully, and then going to VS Code. That we will be doing, but the thing is that I need to explain you how and what is exactly is going to happen in the tree. So first let me explain you on the board here, then we will go back, because you see today I am going to explain you one very important and a very easy way to implement a tree, binary tree here. Binary search tree we will not do in this session, but let me explain you about binary search tree here so that you will understand what is the difference here between binary tree and binary search tree. Today's topic is going to be binary tree. Okay, but let us see, understand here. In this case we are saying that 150 is greater than 100, so it will be placed onto the right hand side, and on the left hand side this is going to be it. I hope so that this is very much clear to all of you. Understood? So I said this is the case. Left hand side smaller values, right hand side bigger values. Now let us say I want to insert 200. So I want to insert 200. Now 200 is greater than 100, so it will go to on the right hand side. Now 200 is even greater than this 150, so it will be placed onto the right hand side of this 150. So basically it is 200, no? So it is 200. So I will write here 200. This is the node. Got it? Now if there is let us say 30 came. Now 30 is smaller than 100 and 30 is even smaller than 50. So 30 will go first here, and it is even smaller than this, so it will go on to the left hand side of the 50. You got my point, guys? Let us say we have 90 to be inserted. Then what we will do is 90 is smaller than 100, so it will go here, but 90 is even greater than 50, so it will go right here. So 90 will be kept right here. You got my point? If I say 130 is greater than 100, but it is lesser than 150, so it will go on to the left hand side. Okay, so 130 will be placed here, and this will be your binary search tree. This is the BST. Where all the elements which are bigger than the root are placed onto the right hand side of every subtree, of every sub node or every sub root in this case, and all the elements which are smaller than the root node will be placed onto the left hand side. Alright guys, I hope so that this is very much clear to all of you. Correct. So now today I want to focus on to this, the binary tree concept. In a binary tree, you can put the data anywhere as you want. There is no such rule that you need to put the data in this way only. Okay, I can put one here, I can put 2, 3, 4, I can put 5 here, I can 6, 7, 8, 9 and 10, like this also I can do. No worries. Okay. I can put any data anywhere into any binary tree like this. It doesn't matter. You got my point? Today, let us focus on to just the simple binary trees, so that in tomorrow's class, when you will do binary search tree, I will be able to take up all the examples from it. Okay. So, one more thing about the operations which we will do on binary tree are going to mostly about the traversal. The most important thing that we will be doing here is going to be traversal. Traversal of trees. When we are trying to do traversal, then what happens is that there are two types of traversals that are done on these kind of trees. Well, if I think about printing the tree, a tree cannot be printed in your output screen like this. It has to print the numbers in sequence, so that you will get to know in which way it is actually printed, and you will understand the tree with that help of that particular example. So, traversal is the key which will actually traverse the whole tree, and it will allow you to print this tree in a proper series. So, with that you will be able to understand how your tree looks like and which node is connected to which node. So, that is the reason why we need to do now traversal in any tree. Either it is binary tree or it is binary search tree, we need to do traversal. To do any type of operation, we need to do traversal. Going till that particular point and then understanding what is the problem is the key here. So, we will do the traversal. Now, traversal are mainly of two categories here. First one is going to be BFS, and then we are going to talk about DFS. Here, BFS stands for breadth first search. Breadth first search, breadth wise, the width wise, or we also call it as level order traversal, where we travel into a particular level like this. You getting my point? We travel the tree like in this format. Understood? Then this, then this, then this, like this. This is what you call as level order traversal or breadth first search, where we go into the breadth wise traversal order. So, if we try to write the breadth order traversal of this, it will be 1, 2, 3, 4, 6, 7, 9, 8, 10, 5. Okay, because the elements are kept here like this. When we are talking about depth first search, here the second one is going to be your depth first search. DFS stands for DEAPTH, depth first search. Depth first search. In a depth first search, we go in depth wise like this, like this, like this, like this. Are you getting my point? So, these yellow ones are depth wise, while the green ones are breadth wise. So, this is breadth first search and this is depth first search. So, basically we are going into depth wise. So, branches by branches by branches, nodes by nodes by nodes connected to each other. This is what you called as DFS. So DFS is the traversal here that we are gonna use. Both of them we are going to learn. Okay. Now in this case, BFS and DFS are the two methods, but there is one complication in this. That DFS will be a little bit complicated to understand at first. Why so? Because you see, in terms of BFS, breadth first search, it is very simple and prominent that you can go into level wise level and just write the numbers of whatever the data is. You can directly traverse it in one particular order and it will do the job. That is fine. That is absolutely clear. Okay. So it is straightforward, simple, that it is going in this way, this way, this way and this way, like that. Okay. So you write the numbers like 1, 2, 3, 4, 6, 7, 9, like proper level wise level. But when you try to do depth first search, depth first search, then you will get confused. Shall I go this way, or shall I go this way, or shall I go this way first, or this way first, or this way first? This is the place you will get confused. So to understand this in a better way, we have DFS again subdivided into different parts. We have number 1, preorder DFS. Then we have in order DFS. We have third, post order DFS. Now in terms of BFS, we don't have pre-order, in order or post order. Why? Because it is straightforward, simple, it is prominent that we are traveling in just one level order and there is nothing into this. You don't have any complication, you don't have to go left or right. But in terms of depth, you need to decide I should go to left first or right first. Okay. So in that case, to solve that, we have these 3 concepts, very important to learn. Okay. Got it? This is the case. Let us understand all of them one by one. So let us understand about that right here. Okay. Correct. So in this case, let us first create a tree and try to traverse. Okay. So I have this, let us say tree. Okay. Let us say I have this tree, and let us say the data which is stored inside is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let's make this a different. Let's make this as 15 and this is 9. Oh, my battery, guys, my battery is about to shut down. Okay, I forgot the laptop's charger, guys. Just give me a minute. I have to connect the charger. So, yeah, I forgot about the charger. Okay, so here we go. We are back on charge and let us continue. Yeah. Now we are on to charge. The laptop is on to charge. Let us continue. So here we have this, and what I'll do is I'll copy the whole thing so that I can reuse it many different times. So right now, if we talk about BFS, if we talk about BFS means breadth first search, then the answer for breadth first search would be straightforward 1, 2, 3, 4, 5, 6, 7, 8, 15 and 9. Why? Why? Because it is level order. In this case, we will travel this level first. 1, 1. Then we will travel this level. 2, 3. Then we will travel this level. 4, 5, 6, 7. Then at last we travel this direction. 8, 15, 9. 8, 15, 9. This is BFS or breadth first search. Looks very easy. Code is a little bit complicated to understand. So we will get there. In after some time we will get in there and try to understand it, how to do that. Okay. Then comes, this was breadth first search. Now with the help of the same tree, we will try to do DFS. Which DFS we should do first? Let us do number 1, pre-order DFS. Okay, this is DFS. Let us do DFS and we will do pre-order traversal now. Okay guys, the trick here is, learn this, very important. The trick here is, if it says pre, guys, this is the cheat code here. If it says pre means before means this. What was the doubt in DFS? What was the doubt in DFS? That we did not know which direction we need to go, right? Either in this branch, or maybe 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 in this branch. We did not know this, right? So whenever it says pre, try to understand this, whenever it says pre, we will say access the data first. What we will say? Access the data. Access the data. D for data. Just listen to this very carefully, Access the data. Okay, whenever it is pre, first thing first, access the data, D for data. Then you go left and right in a natural way. Then you go left and then you go right. Remember this word DLR for pre. See, you need to go to either left or right, but you have to cover both left and right, but also at the same time you need to access the data as well. So the trick here to learn it here is, if it says pre-order means DLR, data left and right, access the data, then go to left and then go to right. So if I want to do a pre-order DFS on this tree, how we will do it? Check it out guys. Whenever you are in this situation where we need to find the pre-ordered DFS, remember DLR. Let us apply the concept of DLR on this tree and understand how it works. Always remember, the execution starts from the root. Execution starts from the root itself here. You got my point? Root is the place where we will start the execution. Okay. So we are standing right here. Chalo, we started the execution. What is this? Access the data. Okay, I accessed the data. I accessed what? I accessed the data. So data is 1. Data is 1. Then I said go towards its left. So right here, DLR. access the data. As soon as you access the data, cut that D. Cut that D. Listen to this very carefully. As soon as you access the data, cut that D. Now you are ending up with data you have accessed, printed the data. Now you want to go towards left, right? So cut that left, go towards left. Now you are here, right here, DLR, right here, DLR. Now again you have to do access the data, cut that D and print that data too. Got my point, guys? Understood this? Then what is coming next? L, cut that L and go towards its left, right here, like this. Okay, in this direction we went, in this direction we went first. What my point? Because we are following the rule of DLR. We are following the rule of DLR. So D stands for data, L stands for left. So we are coming to the left. Now we are here, write DLR. This should be clearly understood, otherwise it will become difficult for you to learn this. Cut the data, access the data, 4, right here 4, right there 4. Then what you are left with? L. L, we will go to left. Now this doesn't have any left, this doesn't have any left. So you do one thing, you check for the next one. Do it has right? Does it has right? Does it has right? No right as well. We don't have the right. So what do you do now? You say I will go back. I will go back. And when I will go back, I will go back. When I will go back, what is left here? R is left here. In the DL was done. So cut that R and go towards R now in this direction. You got my point? And when you went to this direction, right here, D, L, R, access the data first, access the data first. So I access the data, cut that D and access the data. Now you have to go to left, cut that L, go towards its left. You got my point? Right here, D, L, R. Cut that D for a data, access the data, print the data. Then do you have any left node here? No. So you cut that. Do you have any right node here? No. You cut that. Now nothing is left. So you will say I am coming back. Now in here R is left. Is there any right node connected to this 5? No. Cut that. Cut that. Say I am coming back. You see all the nodes are DLR, all is cut here. Cut it down, okay. Now you see here you came back to 2. Now DLR is fully cut. Now we don't have anything to do. You said I am going back. You came back to 1. You came back to 1. And when you came back to 1, you have left with R. You are left with R. You cut down this R and now you follow the path towards right hand side. So what do you see here? You see here 3. Right here DLR. D for data. Cut that data, print that data 3. Okay. Print that data 3. Then you are left with L. Cut that L and go right in this direction. Are you able to understand, guys, what I am trying to say? Say how easy it is, and this is okay. Thank you, trainer Soumya. Oh, the camera is off. 1 minute. Guys, actually I have to manage the camera here. So apologies for that. My camera went off. I am back here. Okay. Thank you, guys. Thank you so much for all your love and support. And let us continue. Thank you, Muhammad Irfan. Yeah, I know. Thank you, trainer Soumya. Thank you so much. Let us continue. All right. Done. Let us continue here. Okay. So we have this DLR. Okay. So in this case, where we were here, we were at the, we have accessed the data, 3 is accessed, we went to left, we are standing here at 6. So I said again, DLR, cut the data, access the data, print the data. Now you are left with L. Go towards L, which is left. You went till 15. Right here, DLR, cut the data, access the data, right here. And go towards its left. There is no left to this 15, there is no right to this 15. So what do you see? You say, I am coming back. Now here you are left with R. Cut that R, go towards that R and write again DLR, cut that D, because you have accessed the data, you printed the data and then you went to L, there is no L or left, there is no right. So what do you say? You do come back. Now you are done with the DLR here, so you say I am coming back. Now here you are only left with R. Cut that R and go towards its right. Okay. Right here, DLR, access the data, cut the data and put that 7 in the answer. Then go towards its left and go towards its right. We don't have left or right. And guys, this is your answer. What is the answer? Your answer is 1, 2, 4, 5, 8, 3, 6, 15, 7, 9 and 7 is the answer. This is your DFS pre-order traversal. I hope so that you have understood this concept really well. I hope so that this is very much clear to all of you. If you have any doubts, you can please let me know. This is the easiest trick to understand this. Ronnie please. Sir, does DLR, data left and right, works for DFS in all its case? No. I'll explain you. Ronnie plays. Let me explain this. That DLR concept doesn't work in all the cases of DFS. I'm coming to that point. Did you understand this concept really well, guys? This is pre-order. Data first, then left and then right. Now, speaking about your doubt, Ronnie, DLR is only for pre. Okay. When you are talking about, in this case, let's do the next one. Now we will do, I'll come to your point, Ronnie plays. Now we are doing DFS. We have already done the pre. Now we will do in order and post order. Yes. Now I am coming to that point. Let me explain that. So DLR only works with pre. Now when we are talking about in order, the next one, in order. You had DLR, you had what? DLR, correct? Now do one thing. In DLR was for pre. Now do one thing. Bring this D in middle and bring this L and R. Bring this L and R in adjacent to this. So this becomes left, data and right now. Easy? Isn't it easy? Ronnie plays. You see, pre means before. So data will be accessed first in pre style. Are you getting my point? Ronnie plays. D means data first. In means data in between. And post means data at the last. So you have three things: DLR, LDR and LRD. You got my point? Except one edge case. Tell me that edge case, Mohammad Irfan. Tell me that edge case, Mohammad Irfan. Okay, so we are doing DFS. We are doing in order. When we are doing in order, we are doing LDR. Okay, we are doing LDR. LDR. Let us apply the concept of LDR, the magic of LDR. So where we will start from? We will start from the root node. Right here, LDR. Cut L. That means you need to go on to its left. Right here. Okay. When you came here onto its left, now you have again LDR. Cut L. That means now you want to go towards its left again. Data we will access later on. So again you say LDR. Cut L because now there is no L left. So now you cut D, and when you cut D, you are accessing the data. So print the data. 4. We printed the data. Is it not visible? Let me just move it a little bit this side. Okay. Yeah. Now it is visible. Okay. Pre-order is DLR and in order is LDR and post order is LRD. Absolutely correct, Ronnie Place. You got the point. Very nice. That is it. So it's, if you can take a rough paper and create a new tree and try to do it before me. Let us see if you are able to do it. Well, I am doing it while explaining, but you try in a rough paper while you are listening to this video. In a rough paper, you create your own tree data structure and there you try to find the pre-order and post-order. Okay. The edge case is when we are using DFS using recursion. Mohammed Irfan, we are going to do DFS with recursion only. But in that case, I will use DLR concept. Trust me, it becomes very easy. With recursion, we will do the concept of DLR, a base case for DFS. Yes, that has to be done. When we are using recursion. When we are using recursion, I will use recursion plus the concept of DLR and all of these things. DLR, LDR and LRD. Okay. Alright, let us continue here and let us finish this up. Let us finish this up. So here we have LDR. Okay. So data is accessed here. Now we will go to its right. Now right is not there. So we will go back. So when we went back here, now we need to access the data. So access the data, print the data. So 2 is the next data. Then go towards its right. So I went to its right, and don't forget to cut this R so that you don't get confused here. And we are on to this. So write LDR. Okay, go towards its left. That means you have to go here left, and you need to write again here LDR. Okay, so cut its left because there is no left, cut its data because now we will have to access the data and write the data, and then cut its right because there is no right. That means we are coming back. Now you have to cut the data and you need to print that data here for this node and then cut right because there is no right again. So in this case we will come back right here, and right is also cut for here. So for this case we will come back to this. Now in this case we will access the data next because left is done. The whole left subtree is done. And when the whole left subtree is done, we will go to 1 and then we will access the data. Cut that data and print that data. Okay. Then okay, I am coming to your point. Crick X Yesh, I am coming to that point. I will read that comment. Let me just finish it very quickly. Okay. I will be a little bit fast now because already I have explained you this. Let me just quickly do it. Okay. So we have printed the root and then we are going towards the right hand side and we will go towards this side here, and here I will say LDR, we will go towards its left. So here we went towards its left, right here LDR, go towards its left again. So we will go towards its left again, and here I will say LDR, and here I will cut the left because we don't have any left again. We will cut the D and print the D which is 15 here, and then we will cut this R because there is no right. So this will come back, and now we will go towards its data. cut that data, print that data, and there is no write, there is write. So we will go and access this write, say again LDR and then cut its left because there is no left, cut its data and access the data which is 9 in this case and print it out, and there is no write. Then because there is no write, we will come back here, this is also done, this is also done, we will go back here, then we will access the data. So let us cut the D and access the data, print the data, and then go toward its write. So that means we came here and this write, and then I said here LDR again, and I cut the left because there is no left, then I cut the data, so I printed the data in this case, and then I went to R which is not there, and once you are done with this whole process, it will again return back, return back, return back, return back, and all the function calls will be over, and as soon as the function call will be over, this is going to be the answer for DFS in order LDR, left, data and right. 4 to 8, we will start from here, 4 2 8 5, then 1 15 6 9 3 7. This is going to be the in order traversal of the tree. Yes. So now what are you saying? 4 2 8 5 1 15 9 15 after 15 9 is it? I have said after 15 6. After 15 6 you will go from 15 to 6, right? Ronnie place. So make a little bit of change. It is after 15 it is 6, then 9. 6 and then 9. After going from 15 you will come back to 6 and then you will access the data, correct? And then you will come back to right. So Ronnie place, there is a small mistake into your answer, that is after 15 you will access 6 first and then go towards 9. Okay. What you are saying, Crick X Yash? Sir, you are running C++ course, what prerequisites are required? So, sir, I am final year student, should I continue the series or watch the full course of DSA, because sir, I have a limited time? Nice question. I have started this placement series just for you guys, those people who are looking for the courses for DSA for the placement series. But if you have a very limited time, we run our online and offline courses also. So if you want to join Coders Arcade as part of this institute, we will train you in a limited time and we will prepare you for your interviews. Plus now also we are started providing internships as well. We are soon about to start internship program where we will be starting internships as well very soon. Okay. So in that case, we will be able to do much more things than what we are right now. Right now, if you want, you can join our DSA course that we will be running. It is both offline and online. Online option is also available. So if you are interested in limited time, we can do crash course for that as well. Okay. If you want everything for free like I am doing, I am not leaving anything. Everything I am teaching you in depth, but in this course, it will take some time. Because see, this is the 16th session. This is the 16th session, and in this 16th session, I have just reached till trees. Now, again, I guess that more 16 or 20 sessions it will take for us to finish up this DSA placement series. I am trying to come live every day, but let us see how much things we can cover in this DSA live session. Yes, Crick X, yes, you can rely on to this series, but this series may take some time. Prerequisite for C++ with DSA is learning C++, mastering object oriented concepts, pointers and dynamic memory allocation. See, 4 or 5 things you need to master as an prerequisite. Crick X, yes, this is for you. Number 1, C++ basics should be clear. Number 2, object oriented should be very clear in C++. If you are confused with object oriented, then I have a dedicated live sessions for 5.5 hours where I have explained C++ object oriented in very much depth, So if you just listen and watch our C++ half an hour, 5.5 an hour course there, it's also a live session like this. Okay, every day I have came live in the last week. The playlist is already created. Recently we have created the playlist. You will see a yellow color thumbnail. There are 5 videos. If you watch those 5 videos, you will master C++ object oriented. Apart from that, first one is C++ basics. Second one is C++ object oriented programming, which I have already created the videos on. You can watch it. Third, pointers. You have to master pointers concept, which I have already created the video for also. If you watch that video, it is a half an hour video. If you watch that video, that will be enough, more than enough for learning DSA. Fourth, dynamic memory allocation like malloc, calloc, realloc. These are there in C programming, but if in C++ you are doing, you should know new and delete keyword, how to use them. You should know that is dynamic memory allocation. And fifth point is call by value, call by reference. Call by value, call by reference in functions. So guys, what all concepts you should know? Basics of C++, then object oriented in C++, pointers in C++, and what else? Dynamic memory allocation in C++, and at last you have this, what did I say just now? Call by value, call by reference. These 5 things are very important. You got it? If you do these 5 things, you are ready to start a DSA course. This is the fast track of, this is the shortest way that you can start learning about DSA. You understood this really well, all of you guys? If you have any doubts, please do let me know. I am there. Okay. And about DSA, you got to know about this requirement, right? Prerequisite. For DSA, this series which you are watching right now, if you follow it from the episode 1 till this current episode, you will have enough knowledge to start executing codes on lead code and coding ninjas. If you watch this series, every day I am coming live. If you catch up to me in every day's live, you will be eligible to start solving problems on lead code, as I said, and coding ninjas. These 2 platforms, if you do, you will have enough and plenty knowledge to crack an interview. But if you want a fast track course and you want everything to be covered, everything at point, then you have to join our course. Now that course is paid, that is a different part, but for free we are providing everything for free in YouTube, but this is a little bit slower. But if you want, you can join our online courses or maybe offline courses according to your leisure. We are located in Bangalore, and if you are available in Bangalore, you can join our offline course. If you are not available in Bangalore, you can join our online course, where I will be teaching DSA. Whatever I am teaching here, I will be focused more onto placements, but here I get continuous comments here like yours comments, so I keep on talking in between. But in my DSA course, I will be dedicatedly sitting with you guys, explaining each and everything, hand-on experience, and also we are going to also start our internship platform, where we are going to provide internships as well. Very soon we are starting. So update, keep following us on different social medias. Also join our Telegram as well. On Telegram, I will put up the link of Telegram in the description below. Please join our Telegram and WhatsApp community. There we will keep on posting our this job postings and interview sessions. Also, we will be posting our the batches info. I hope so you are getting my point, what I am trying to say. Okay. So follow us on social media to stay connected with us. Also, very soon I am trying my level best to get connections with multiple companies for placements also. So wish me luck. If this happens, I will be able to provide you placements as well in different companies for IT, where I will, of course I am not guaranteeing you that you will get the placement, but I am saying that I will be taking you directly to the interview without any technical written round. That is what I am saying. I am trying my best to make it happen. Let us see how it happens. So pray for us also, so that I can connect with multiple companies for placements also. Very soon, if everything goes well, we will be able to provide placements to you subscribers, our subscribers like you and our family like this. And yeah, that's it. I hope so that all your doubts are very much clear. Internships, very soon, we are working on it. And this also. Sir, please post it in our college group also. Oh, Ronnie Place, you are from the college where I am going right now. Oh, I did not know that you are from my class. Okay, yeah, I will be posting that. I will be posting that in the college group, but not right now. After the training gets over. Okay, Ronnie? Got it? Sir, post it in our college group also. Got it. I will post it very soon, but not right now, after the session gets over. On a personal level, I will come to your class and then I will announce it in the class. Okay. But this is from our side, company side, Coders Arcade side. That is what I want to emphasize more on too. Hope so that you are getting my point, what I am trying to say. Right? Well, hope so that you have understood this really well. If you have any doubts, please do let me know right away in the chat here. Chat is going on. I will be seeing your chats. But I hope so that today's concept you have understood really well. Time is already over. I did not get time to code for this directly, but we are left with our DFS post order. So can we do post order in homework, or shall I do it right away right now? You want me to do post order also? Shall I do post order tomorrow in tomorrow's class as soon as I join here, or you want me to do post order right here? Sir, I am from Pakistan. Shall we be able to get also? Shall we be able to get also? Sir, I am from Pakistan. Shall we be able to get also? Yes, definitely. Why not? We will try our level best, but then you need to plan accordingly when we will start doing placements. It may take some time, but yeah, we will be able to do it. We will try to do something, don't worry. I am still there. We will try to do something on this. Okay? Yes, we will have a long convo about this. Ronnie Place. Absolutely fine. Okay. What about this class, guys? You want me to do the post order DFS also, or are you going to do it in the homework for me tomorrow? Tomorrow same time, 7 o'clock, I will be coming back, continuing from where I have left. In today's class, because of the theory concepts, this was also absolutely important, because if you don't know about this, you will never be able to code. So this is also very important thing to do for you, for us, for everyone. And after we have understood this, we will start coding. In tomorrow's class, we will code. But you tell me, you want me to finish this up and do post order traversal also? Yes or no? Accordingly, I will continue the live session, because I need to change the battery of this camera also, guys. Accordingly, I will do that. Let us see. Internships and jobs. Yeah, internship. Internship is going to be totally offline though, Mohammed. Post order, we will provide the answer in tomorrow's class. That is fine. I will definitely check your notebook. But what about other other viewers also, like Mohammad Irfan and Krik X Yash? Okay, let's do one thing. My camera is also about to die. What we will do is, let us continue this class tomorrow. Okay, and I will be I will be continuing this with post order DFS, and tomorrow we will start coding on this. We will quickly revise our today's class. In tomorrow's class we will quickly revise that. So we have done all of this in today's class. So all of that I will again revise in tomorrow's class, and we will start the coding for it. Okay. I hope so that this is very much clear to all of you. Today's class, if you have any doubts, please ask me in tomorrow's class as soon as I am back. And guys, thank you so much for watching. I am going to end this live session. My camera is about to die. It can die anytime now. So I am saying this, that bye bye. I will see you. Still people are there watching and coming, but you guys are not typing anything. At least say bye bye. I will see you again in tomorrow's class. Shall we? Tomorrow's class, same time, 7 o'clock in the evening, continuing from here, plus code. Tomorrow's class, do not miss, because tomorrow I will tell you how easy it is to implement a basic binary tree and use it for traversal. DFS traversal is going to be very easy. Trust me, this is going to be very strong. This is going to be very easy. Tomorrow you will see the easiest way that you might have not even seen in your life again for binary trees concept. Okay? Alright guys. Thank you so much. So I'll be get going now. Bye bye Ronnie Plays. Bye bye Muhammad Irfan. Bye bye Craig X Yesh. Bye bye people. Alright, so I will see you. Thank you for watching guys. Don't forget to like, share and subscribe, and don't forget to share this live stream to people who are in need of learning DSA. This is all for free. Thank you for watching. This is Ashank David signing off. I'll see you back in tomorrow's session at 7 o'clock straight, continuing from here. That's all. Thank you guys.